Chalo, let's start. Let's start. Okay. Good evening. Okay, we'll directly start with the topic because topic is very big. Okay, and days are limited. So today we won't do the revision. Okay. Random variable. A random variable is a function that associates a real number with each element. So S is a sample space such that X random variable is a function X such that S belongs to R and R is a real number line. So S is a sample space of the random experiment and R is the number line. So you have to remember always each element and then X S tends to R. Tends to means it moves towards R. R is a real number line. Okay, this is a number line which we have studied in our school level. In our chapter number 2 also, discrete and continuous. If a random variable takes finite number or countable infinite number of possibilities, it is called as discrete. Countable, like apples, mangoes, which can be counted. Hi, good evening. So age, number of arrivals in the clinic, number of accidents, these can be counted. Continuous means infinite number of possibilities, which takes infinite number of possibilities. It's called as continuous, means percentage of marks. Percentage of marks means it can take various possibilities. Okay. So infinite number of possibilities, that is percentage of marks. And weight also. Why weight? Weight is what? Mass into gravity. Okay. So that's why it will take infinite number of possibilities because gravity keeps on changing. Percentage of marks, that will also, percentage is same but the absolute numbers will keep on changing. Okay. Probability distribution of random variables. Now this is all theory which you have to remember it by heart. A probability distribution is a statistical function that describes all the possible values of the random variable X . So all the possible values of the random variable X and its corresponding probabilities that X can take within a given range. Now see here, you have studied sampling distribution, you have studied normal distribution. At that time, what did I tell you? If number of samples are less, then it's sampling. As it goes on increasing, it becomes normal. From normal, still more increase, so it becomes probability. From probability, it still increase, then it's called as Poisson. Last one means binomial and then Poisson. Okay. So probability means what? It is again a distribution only, similar to sampling distribution. Okay. So probability distribution is a statistical function that describes all the possible values of random variable X and its corresponding values of that X can take. Okay. The range will be bounded between minimum and maximum possible values. Now this probability mass function, this question comes nowadays. Only in definition it comes. Huh? You don't have to study much about this. It's only definition and there's one formula for this. By looking at this formula only you will understand it. I'll show you. Number of customers arriving in the bank at a particular time is a discrete random variable. The values of random variable along with its corresponding probabilities is discrete probability distribution. It is called as probability mass function. So you have to remember what? Discrete probability distribution. Discrete probability distribution. This word you have to remember, DPD. So that is called as probability mass function. Okay. So probability mass function is having one formula. Let me see if it's given over here. It's over here. It's there in one of the numericals. I'll give you at that time. Okay. Cumulative distribution function of random variable. Again theory. See this. All this is theory. You have to just rectify, learn. Nothing else. You have to only learn this part. Then second, probability density function. Expected returns of a particular stock is a continuous random variable. The range of values of random variable with possible values is continuous probability distribution and called as PDF. probability density function. Again, theory, you have to remember it by heart. This part, okay? Nothing can be, means there's no explanation to this. It's just a wording. The range of values, random variables with possible values, is a continuous probability distribution. That's it. Okay? So only thing which important needs is whenever you see this word range, always remember it's continuous. Whenever you see the word individual, always remember it's discrete. Okay? So this is one hint which you can see. Remaining this thing, nobody will ask you anything like this. Okay? Only this definition will be asked to you. Cumulative distribution function. So again, let x be a random variable of PMS or PDF, means probability distribution or mass. Fx such that P probability of capital X is less than or equal to X is a cumulative distribution function. Again, forget this, nobody is going to ask you that much. Okay? What I tell you from the exam point of view, remember this definition, learn this or at least go through this definition. This PDF and that PMF. These three definitions, you go through them, read them. I've given it in that PDF also. The PDF which I have shared, master PDF, there also you get this. So you can read there also, that much is also enough. Got it? Expected and standard deviation of random variable. So expected and standard. Now the mean expected value of random variable, sometimes denoted as P, is a value that is expected to occur per repetition. So what is the expected return versus the actual return? That's the only difference. If an experiment is repeated on a large number of times, expectation is the average or mean of the distribution. So expectation is average or mean of the distribution. Remember this. This we have studied it in our sampling also. There also same logic. For discrete random function variable, E of x is defined as Ex equals to summation x fx. For discrete it is summation, and for continuous it is integration. Remember, only that is the difference. For discrete it is summation, for continuous it is integration. These two you have to remember. Okay? Where fx is a probability density function and here probability mass function. So in discrete it is mass function and in continuous it is density function. Okay? My God, again they have brought in over here. Don't study all these, only study this part. Standard deviation equals to square root of variance. This much is important for you. Okay? If you get this discrete, remember summation. If you get continuous, you remember integration. These two you'll understand. If you remember, what did I tell you? For discrete it is summation, for continuous it is integration. Okay? Properties of expectation and variance. E of Ax plus B equals to A into Ex plus B. So again remembrance, nothing else. A into Ex expectation plus B. Variance of Ax plus B equals to A square Vx. These two you have to just remember it, because here all whatever we are seeing today up till now is just rectify, nothing else. You have to go through it and the marks will be there on this. 3 definitions and 1 on this discrete and continuous. 1 out of these will be there. Find the expectation, variance, standard deviation and CDF, cumulative density function of x when x has the following probability distribution. Also find E of 2x plus 3 and V of 2x plus 3. Now all the formulae, x is given, fx is given. Okay? What we have to find first is expectation. What is expectation? So expectation of x equals to summation. Here it is summation of x into fx. Why x into fx? Because here we are taking discrete values. See this 1, 2, 3 countable. This is countable. So it is discrete. So E of x equals to x of x. So that is equal to 1.9. X of x means multiply this. 1 into 0.3, 2 into 0.5, 3 into 0.2. Add them, you will get it as 1.9 over here. If you multiply this, 0.3 into 1, 0.2 into 5, so that is 1. So 1.3, and this is 0.6, so 1.9. Second is variance. Variance equals to what? E into x square. See this. This expectation, whatever you get, E is for x. So E of x square now. So Ex square minus Ex the whole square. Now this formula, if you see, variance, this is same as your this correlation formula. Summation x square upon n minus x bar square. Similar formula is this. So Ex square is what? Ex square. Look at the same over here. X square into fx. This was Ex, so x into fx. Ex square will be x square into fx. So look at this, x square into fx minus Ex the whole square. So x into fx the whole square. So now x square into fx. What is x square? 1. 1 square is 2 into 0.3. 1 square is 1 into 0.3. So same. Here 2 square is 4 into 0.5. Okay, so 2. 3 square is 9 into 0.2. So 9 to the 18, 1.8. So this is what? 2. 1.8 means 3.8. And this is 0.3. So it is 3.8 and 0.3. So 4.1. So you get it as 4.1 over here. Minus this x fx the whole square. See this Ex the whole square. So that is 1.9. So it is 4.1 minus 1.9 square. So it becomes 0.49. Now standard deviation. Standard deviation is just the square root. So square root of 0.49. So 0.7. So standard deviation you have got it as 0.7. CDF, cumulative distribution function. So that is equal to fx. Means this is just a formula fx such that p is x less than or equal to x. See this one. This cumulative distribution function. Let x be a random variable. Their PMF, probability, mass function or density function. So x is a random variable with PMF or PDF. So in that case, fx equals to probability of x less than or equal to x is a CDF, cumulative distribution function. So only you remember this fx equals to p x less than or equal to small x. So this question, if it comes, it will come as a 5-mark case study. This part, 5 marks case study. Here, this answer is so simple that CDF equals to p of x less than or equal to x. Only this is the answer. So CDF also you have got it. Now next is what? So you have got standard deviation, then CDF. When x has the following probability distribution, find E2 of x plus 3. Now this E2 of x plus 3 equals to what? E2 of x plus 3. What is x? 2 of x. So this we have got it as summation. So this is all summation. 2 into 1.9 plus 3. And what is V? You see this formula is over here. Was it E2 of Eax plus B? Yeah, this one. Eax plus B equals to A into Ex plus B, and Vax plus B equals to A square Vx. A square into Vx. So same formula we are using it over here. So E2x plus 3Ax plus B equals to E into this x A into this what A into Ex plus B. So Ex plus B is what? A is 2, Ex is 1.9 plus B, that is 3. And this Vx, this I'll have to cancel this. This is separate. V of 2x plus 3 equals to 2 square into Vx, A square into Vx. So what is A square into Vx? That means this is the only answer, A square into Vx. That's what you require. And CDF also require, that is P of x less than or equal to x. right? Difficult one, huh? Really difficult. These are just to be rectified, nothing else. Only learn. You have to go through this 2-3 times because no brains can be applied over here. Okay? Yeah. Hmm. What is this? This is separate. Yeah. So now, E done. So E 2x plus 3 and V 2x plus 3. That's it. Okay. Next one. Find the value of K, expectation, variance, standard deviation, and CDF of X when X has the following distribution. Okay. So X is given and Fx is given. So we have to find out the value of K now. Okay. Now this, let me see. This is equal to, say this. This is a continuous function. Okay. So it is, say this, summation fx into dx. So summation fx into dx equals to 1. Whenever you have this continuous function, has a following. So here whenever you have this continuous function, it comes under the normal distribution curve. So that is equal to this. So the total area of this is 1. So when the total area of this is 1, what does it mean? When x equals to 0, then x equals to 0, fx equals to k. So this x equals to 0 means somewhere over here. X equals to 1, so this. So that is equal to again k. When x equals to 2, this part here, it is k plus 0.1. So now if you add these three, this k plus k plus k plus 0.1. So the total area of this becomes 1. So k plus k plus k plus 0.1 equals to 1. So 3k plus 0.1 equals to 1. So 3k equals to, take 0.1 on this side, so 0.9, so k equals to 0.3. So the k value which you have got is 0.3. Always remember the area under the curve is equal to 1. So add all these and that is equal to 1. Okay? Same thing I might have done it over here also. What is asked over here? Yeah. Find the value of k first, then expectation. Now expectation is what? Again the same formula. E of this summation of x into fx. So x, this is summation. So x into fx means what? What is x given? 0. And fx is 0.3. It's given in the question. 1 into 0.3, 2 into 0.4. So if you add this, you'll get it as 1.4. This becomes 0.8 and this becomes 0.3. So 1.4. Vx. So ex square minus ex the whole square. So again the same one. Ex square means x square fx. Do the same thing again. So 0 square into 3, 1 square into 0.3, 2 square into 0.4. Okay, 4 into 0.4. So if you solve this, you'll get it as 1.9 again over here. Minus xfx the whole square. So that is 1.1. 1.1 square. So it is 0.69. So variance of x is 0.69. Expectation of x is 1.1. Standard deviation. So standard deviation is square root of variance. So square root of 0.69. So 0.83. Now CDF. CDF equals to P of x less than or equal to x. For fx equals to 0 means this is a basic answer. P of x less than or equal to x. So now 0 to x less than 0 less than x less than 1. So for this part it is 0.3. How come 0.3? 0.3 means starting from here 0 and is 0.3. Add these two. So here up to 1 it becomes 0.3. Up to less than 1 it becomes 0.3. Suppose if I want to calculate up to 2. So it will be what? 0 plus 0.3 plus 0.6. So it is up to 2 if I want to calculate from start. So it will be 0.9. If I want from 1 to 2, see this 1 less than or equal to x less than 2. So in this case it is only 0.6. And greater than 2 it is 1. This part is 1. Okay. So all these things depends on that normal distribution curve. Okay. Normal distribution curve means this. Okay, the total area is equal to 1. Always remember. So this, when I say x equals to 0, means here x equals to 0. This is x. This is x. Here it is 0. Here it is 1. Here it is 2. 2. So this area from 0 to 2 is total 1. Greater than 2 if I want. So this greater than 2 means it will only come 1, because this becomes 0. This becomes almost 0. So here we don't add anything. So if x is greater than 2, it becomes only 1. Complete area is 1. Okay? Now a bit simpler one. Earlier two were, that was very difficult. Now it's a bit simple. Bernoulli distribution. Model experiment that can only succeed or fail. It has only two results possible. Only one trial. Means flipping one coin. Suppose if I flip a coin in the air. So that is Bernoulli distribution. I can have only two results. Either I can have head or I can have tail. I can't have both. So includes flipping of a coin, choosing a female from a population. Okay, choosing a female from the population. Okay, so that is basically Bernoulli. Even I can say choosing a male from the population, same thing. Bernoulli random variable takes the values 1 to 0 with probabilities p and 1 minus p. So 1 minus p is also called as q. So Bernoulli means what? There is only one trial. Second part is binomial. When I keep on repeating the Bernoulli, see this. Bernoulli distribution is for a single trial. Many repetitions of this trial is binomial. A fixed number of observations. Many repetitions but a fixed number. Means I can have 100 trials, 200 trials, but fixed number. I know the number of trials. That is called as a binary random variable. Binary random means binomial. Constant probability P and Q. Q means 1 minus P. Is for each observation. Here, each observation is separate. In binomial, always remember, each observation is separate. Suppose if I flip a coin 10 times. Okay, suppose if I flip a coin 10 times, then it's called as binomial. Okay, so if I flip a coin only once, it is called as Bernoulli. If I flip a coin more than one, then it's called as binomial. Okay, and every trial is independent. Remember, every trial is independent. It has nothing to do with the earlier trials. Means if I flip a coin, then I cannot say if I get 4 times I get head, I cannot say that 5th time I'll be having head only. Okay, so binomial distribution is given by this formula: NCK P raised to K and Q raised to N minus this Q raised to N minus K. See this: NCK K into P raised to K Q raised to N minus K. Okay, N minus K. This is the formula for binomial distribution. NCK means what? We have seen this: N factorial upon K factorial upon N minus K factorial. P means success. Q means that what is required. What is required is always known as Q. K. Okay, required equals to K. Sometimes we call it R also. Okay, required equals to K or R. We can call it anything. Okay, N is a total, P is a success, Q is a failure. Okay. In binomial distribution, remember this formula: mean equals to NP, variance equals to NPQ. You can directly remember this as NPQ. Variance equals to NPQ. Similarly, if you know the variance, then standard deviation equals to standard deviation. What will be the standard deviation? If I know the variance, see this: variance equals to NPQ. So standard deviation equals to root of NPQ. Okay, root of NPQ. Standard deviation is always what? Square root of variance. Standard error is what? Standard error. What is standard error? Root of PQ upon N. Remember these formulas. PQ upon N for binomial distribution. Okay. Now this skewness and kurtosis, I don't think they'll be asking you this, because this is already there in your earlier chapter. A binomial distribution is symmetric if P equals to Q equals to 0.5. P equals to Q equals to 0.5. Okay. Now if you want to study this measure of skewness, that is A, that is 1 minus 2P the whole square upon NPQ. And measure of kurtosis, A2, 3 plus 1 minus 6PQ upon NPQ. Now this you have to just, if possible, remember. If possible, remember, because this is very tough. But this mean, variance, standard deviation, you have to remember it, and standard error. Okay. If P is less than 0.5, distribution is positively skewed. If P is greater than 0.5, distribution is negatively skewed. Positively skewed means what? This is here, more line is on the right side. More distance or more slant is on the right side. Negatively skewed means what? More slant is on the left side. This is negative skew. We have seen this in our earlier chapter. Mode equals to n plus 1 into P. Now see this, you have studied this mean, mode, median earlier also in the chapter of sampling distribution, right? But here also it is there. See here, mean, mode, median will be there in everywhere. Sampling, normal, and by this Bernoulli, this probability. Okay. So m equals to n plus 1 into P. If m is not an integer, mode is the integral part lying between m minus 2 and m. This is a theory purpose. Again, remember only. M is not an integer, mode is the integral part lying between m minus 2 and m. If m is an integer, there are two modes. Thus, the distribution is bimodal. Two modes are m minus 1 and m. Now, this comes in the theory part in the exam. Okay. If m is not an integer, then mode is what? M minus 2 and m. If m is an integer, then mode is what? M minus 1 and m. Okay. Remember this again, by heart this. N equals to 12, P equals to 1 upon 2, Ex equals to NP, that is equal to 6. What is the NP? NP equals to, remember, this is known as mean. In binomial, this is known as mean. So mean equals to NP, that is equal to 6. Variance equals to NPQ, that is equal to 3. All this is given to you in exam. All this is given. Okay, means this problem, in this problem, n equals to 12, p equals to 1 upon 2. This much is given to you in exam. N equals to 12 and p equals to 1 upon 2. So when this much is given to you in exam, you have to find the remaining. You have to find the remaining things. See, these are two separate problems. This is problem number 2 and this is problem number 3 upon 2. So if p equals to 1 upon 2, what is q? Q equals to 1 minus p. Q is always known as a failure. So 1 minus 1 upon 2. So that is equal to 1 upon 2. So mean equals to what? NP. 12 into 1 upon 2. So that is equal to 6. Variance equals to what? NPQ. So 12 into 1 upon 2 into 1 upon 2. So 1 upon 4. So 12 upon 4. So that is equal to 3. Okay. Calculate mean, standard deviation, skewness of kurtosis, mode of binomial distribution, where all these things are given. P equals to 0.7, N equals to 60. Find Px equals to 0. Now this problem won't be asked to you that much. Okay. But then also, let's do it here. If it is asked, if you have a hard luck, then what to do? Isn't it? If you have a hard luck, then many times it happens that what we don't study, that only comes in exam. So now, This is NPQ. What is this is a binomial. Okay. In binomial, NCX, P raised to X and Q raised to N minus X. Just now we saw this K. So instead of K, we are taking X now. So this is the binomial problem. So if this is the binomial problem, what do we want first? Mean. Mean equals to N into P. So N is what? 0.7. N is 60. P is 0.7. So 60 into 0.7, 42. Mean equals to 42. Standard deviation. For that you need variance. Variance equals to NPQ. So NP you know 42. 60 into 0.7 into Q is what? 0.3. So 60 into zero point 0.7 into 0.3. So it will be 12.6. So standard deviation is what then? We want standard deviation over here. So that is equal to what? Square root of variance. So that is equal to 3.55. Square root of 12.6, 3.55. Now skewness of measure of skewness. 1 minus 2p the whole square. The whole upon NPQ upon variance. So if you can remember, then only remember. Don't get extra stress on your head because of this, okay? 1 minus 2p the whole square upon NPQ, that is skewness. So all the values you have, 2p, p you know, 0.7, NPQ you have found out just now somewhere, this 12.6. So do this, 1 minus 2 into p 0.7 the whole square upon 12.6. You'll get this answer as 0.0126. That is measure of skewness. Okay. Yeah, there is a relationship of P and Q. Q is always equal to 1 minus P. Q is always equal to 1 minus P. Okay, there is always a relation because Q is known as a failure. So measure of skewness is this, 1 minus 2P the whole square upon NPQ. Measure of kurtosis. Okay. Now look at this. What is P? P is known as, what is P? P we got it 0.7. So 0.7 means greater than 5. So it is negatively skewed. We just now saw if P is greater than 0.5, it is negatively skewed. So this is negatively skewed. Measure of kurtosis. 3 plus 1 minus 6 PQ upon NPQ. So that is equal to 2.98. Plateau kurtic. We have seen this in our earlier chapter. Next, what do we require? Mode. It is mode. Last one is mode. So mode equals to n plus 1 into p. N plus 1 into p. So n is 42 plus 1 into p is 0.7. So you get this, some answer is mode is 42 over here. Okay. Do the multiplication. I think so this answer is wrongly printed over here. N plus 1. What is n? N, okay, 60. 61 into 0.7. So it is 42. Correct. It's rightly printed. This is not required by you. Okay. Poisson. This is a third type of probability. Binomial distribution describes probabilities for success with a certain number of trials. See here, binomial means what? We have certain number, fixed number of trials, 50 trials, 100 trials. The Poisson distribution applies to success over a time period or an area. Events happen at a constant rate over time. See here, important part about Poisson is it happens at a constant rate. Something is constant over here in Poisson. Okay, just one sec. Chalo, yeah. So, binomial is always related to fixed number of trials. 50 trials, 100 trials. Suppose if I give you one trial, so it is called as what? Who can tell me? Suppose if it is only one trial, so it is called as which type of distribution? Binomial, Bernoulli, or Poisson? Only one trial. It is called as only one trial. Bernoulli. Limited number of trials, binomial. And infinite number of trials, that is Poisson. Heavy number of trials, that is Poisson. Okay, got it? Bernoulli, binomial, then Poisson. Single trial, Bernoulli, limited trials, binomial, and last one, infinite number of trials, Poisson. One thing about Poisson is how will you understand whether any problem is of Poisson or not? There will be something constant over here, constant. Okay, so event happens at a constant rate over time. The Poisson distribution gives the probability of X number of events occurring in time t. For example, like the biotechnology firm which files the patents. Patents are always filed using the Poisson distribution. Or spread of the virus, that coronavirus, that spread through Poisson distribution only. That is very important. Okay. So Poisson distribution is used in all these trials. Okay. Vaccine patents or any virus spreading, that is always done under this Poisson distribution. This is the formula. Lambda raised to k e raised to minus lambda upon k factorial. This is the formula for Poisson. E is constant, 2.718 or 2.72 you can remember. Lambda is always given, which is constant. K is always asked. So lambda equals to constant. Remember, something constant given. Lambda equals to given equals to some constant happening. Constant happening. Something is happening constant over there, that is known as lambda. So I'll show you that. Okay, this is lambda. Lambda means like this, lambda. K is always asked. What is K? That is always asked. When we'll solve the numericals, you'll get it. Okay. Some examples of Poisson distribution are number of misprints on a page of a book, number of people in a community living to 100 years of age, number of wrong telephone numbers that are dialed in a day, number of transistors that fail on the first day of the use, number of customers entering a post office on a given day. All these are Poisson. Okay. Now this post office can be bank also. Number of customers entering a bank. Okay. Mean equals to lambda. Variance equals to lambda. Both are lambda over here for Poisson. Measure of skewness, that is beta 1 equals to 1 upon lambda. Measure of kurtosis, beta 2 equals to 3 plus 1 upon lambda. Remember this by heart. Okay. That was for binomial. Earlier, skewness and kurtosis, 1 minus 2p the whole square upon npq. That was for binomial. This is for Poisson. If lambda is not an integer mode in the integral part lying between, forget this. This is of no use. Okay. So remember this. Measure of kurtosis beta 1 equals to 1 upon lambda, and measure of kurtosis beta 2. Measure of skewness, sorry, beta 1 equals to 1 upon lambda. Kurtosis beta 2 equals to 3 plus 1 upon lambda. Remember these by heart. Okay. When are two modes in this? The two modes are whenever this lambda is not an integer mode and an integral part lying between lambda minus 1 and lambda. So if lambda is not an integer mode in the integral part lying between lambda minus 1 and lambda, and if lambda is an integer, there are two modes. Now what you have to remember from exam point of view is if lambda is an integer, there will be two modes. Only remember this part. Okay. So if lambda is an integer, this question is asked. If lambda is an integer in Poisson distribution, Then how many modes will be there? 1, 2, 3, 4. They'll give you the option. So there will be two modes. Always remember. And what are the two modes? Lambda minus 1 and lambda. These are the two modes. Okay. The COVID cases in Pune are occurring at a rate of about 2 per hour. So now what did I say about poison? Something is happening constant. So what is happening constant? COVID cases are happening at about 2 per hour. So this is constant. What is this? Lambda. Something constant happening. Look at this. Lambda equals to constant happening. So this is 2 per hour. This is lambda. Okay. What is the probability that you will get 0 cases in next 1 hour? So what is required now? Required is always k. So now what is the formula? Lambda raised to k e raised to minus lambda upon k factorial. This is the formula for probability. What is lambda? Constant. What is constant? 2. 2 raised to k is what? K raised to 0 cases. So k equals to 0. So 2 raised to 0 into e raised to minus lambda. What is lambda? Lambda is this 2. Okay. So this e raised to minus 2. So this e raised to minus 2 goes down. So it is e square. So lambda raised to k upon e square into k factorial. What is k required is 0. So k factorial is 1. 0 factorial is 1. What is lambda raised to k? 2 raised to k is what? 0. 2 raised to 0 is anything raised to 0 is 1. So 1 upon e square. So now 1 upon 2.713 square. If you do the total over here, you will get it as 0.135. This is your answer. 0.135. So 0 cases happening is 0.135. Okay. Now if I ask you, instead of 0 cases, I'll ask you 1 case. So k will be equal to what? 1 then. 1. Okay. So 2 raised to 1, right? 2 raised to 1, and this e raised to minus 2, that is same. And 1 factorial, that is also same. So 2 raised to 1, right? So it is 2 over here, 2. So your answer will be double. So 0.27 something, right? 0.27 will be the probability. Got it? If we have number 1 case, okay? If I require the case, okay, now you solve and give me. If number of cases required is 2, if I require 2 cases in the next hour, then what will be the probability? 2 cases I require, 2 cases. So now k equals to what? 2. So what is lambda? Lambda is 2. K is 2 again. So 2 raised to 2, 4. This is same. And 2 factorial is 2 only. So 4 divided by 2, again 2. So it is 0.7 again. 0.7 it will be. Okay, if lambda equals to 2, means k equals to 2 if 2 cases are required. Now I'll ask you one more question. If 3 cases are required, then 3 cases. Can anyone give me the answer? If 3 cases are required, 3 cases of COVID are required. In that case, what can be the answer? So lambda raised to k, 2 raised to k is what? 3, right? 2 raised to 3. So that is equal to 8. So 8 upon, what is this? 2.713 square, right? So 8 upon 2.7133 square. So that is equal to 8 upon square of 2.713. So 1.086. And that divided by again 3 factorial. So 3 factorial is 6, right? 3 into 2 into 1. So that is equal to 0.1811. So probability, have you got anyone? 0.1811. This is your probability. Okay? For x equals to 3, everyone try this at home also. For x, see this, if lambda 0 cases are required, then probability is 0.135. If 1 case is required, 1 then probability equals to 0.7. If two cases are required, then probability equals to 0.7 again. If three cases are required, then it is 0.118. Okay, this you try it at home, everyone. I have shown you just now, but again you try it at home. Okay, again you try it at home without fail. Look at this. Births in the hospital are occurring at an average rate of 1.8 births per hour. So what is this? This is lambda. Something happening is constant over here, 1.8 births per hour. So that is lambda. What is the probability of 4 births in a given hour? 4. So x equals to 4 or k equals to 4. Now use it again. So what is probability? E raised to lambda raised to k into e raised to lambda upon k factorial, or x you write it over here. So lambda is what? 1.8. 1.8 raised to x. What is x? 4 is required. 4. So 1.8 raised to 4 into e raised to minus 1.8 upon x factorial, 4 factorial. Okay. So you solve this. Can anyone get this answer? 0.073 using this Calcium, whatever ways you can. You have to get this answer as 0.073. Okay. What is the probability of observing more than or equal to 2 births in a given hour at the hospital? So more than or equal to 2 births. So now what do I want? More than or equal to 2 births. So P of x greater than or equal to 2. It means what? X greater than or equal to 2 means what? This birth can be 2 or 3 or 4 or 5 or 6, infinite. You can't calculate this. So that what you have to do? It should be x or greater than x. So that is equal to 1 minus x, probability of x equals to 0 or x equals to 1. So probability of x equals to 1 minus P of here. What is, if you can't find infinite one, what you have to do? 1 minus P of before that. Probability of x equals to 0 or x plus x equals to 1. Both these combined. So probability of x equals to 0 is what? Again do this. X equals to 0. E raised to minus 1.8 into 18 raised to 0 upon 0 factorial. So this is equal to 1. So e raised to minus 1.8 is equal to what? Get this answer. E raised to minus 1.8. So 2.712. Okay. 2.712 raised to, one second, 2.712 raised to, what is this? Minus 1.8, right? So minus, no, 1.8, one second, 1.8. So equals to 0.165. So this e raised to this minus 1.8 is 0.165. So this you have to remember, 0.165. Look at this. So x equals to 0 equals to 0.16529 and x equals to 1 equals to 0.2973. Same method again. Just put value of x as 1 and you'll get this as 0.538. Okay. Yeah. So we'll stop over here because too heavy, isn't it? It has become too heavy for you today. Very difficult one and too heavy because this chapter is only heavy. But this probability. Okay, chalo, bye everyone. Okay, tomorrow. Chalo, bye, bye, bye. Do the practice of this very difficult chapter, very difficult.